How's it going, Calc kids? Today we're looking at 2.1. We're going to talk about rates of change and limits. Limits are what calculus is all about, okay? So first thing we got to talk about is average and instantaneous speed. In a few weeks, months, we'll be learning about how to find instantaneous speed a different way. But for now, we're going to use this method. Okay. First part of noteworthy would be that gravity affects an object in this equation. Okay. If you drop something off a cliff, you can tell how far away it is by plugging it into 16 times how many seconds it has been falling squared. Okay. So let's take a look at example. Oh, my head's gonna be down there. Suppose you're throwing a penny off the Empire State Building. That's a penny. And that's you. Okay? And it's been falling for 4 seconds. A question they might ask you is find the average speed. Okay? So here's what we do. We know average is your total over the number it's been going. You know, like miles per hour, how many miles you went in 1 hour. So first we have to find that total. To do that, we plug in our number of seconds into the equation, right? So we see how far it actually fell. Well, we get 16 times 16, which is 256, right? Yeah, I just had to double check. So that penny's fallen 256 feet. Okay? Now, how long has it been falling? Well, it's fallen 256 feet in 4 seconds, right? So my average speed, when I divide that out, is going to be 64 feet a second. Okay? That's all there is to it, guys. Plug in the equation, divide by how long it's been falling. Average speed. Moving on. Limits. Don't write this down, but read it and think about it. You write your limit like so. Okay, I'm just kidding. Write this down. Okay. But saying 0 is less than x minus your c, which you approach, which is less than your delta, as you approach, or as it goes to your f of x minus your limit, is going to be less than your epsilon. What? Your limit is what number you approach with your function as you approach a certain number. Easier to look at. I would write this. Okay. This limit as x approaches c, or the limit of f of x as x approaches c, is equal to L. That means as we get closer and closer to that c, our equation is going to equal L. Okay? And I got a picture to show you when you're done writing this. If we look at a limit, these are 3 different functions, right? F of x, g of x, h of x. Now, as you approach 1 on f of x, your limit is 2. Okay? Even though at 2, there's no value there. Okay? When you plug 1 that function, it's undefined. But it doesn't matter because you're approaching 2. You're getting close to it. That's what a limit is. It's what are you approaching. Okay? Same with g. Your limit is also 2. Even though you know when you plug 1 into that function, it equals 1. Okay? But you get closer and closer to 2 as you approach that limit. Okay? And even if it equals 1 or 2, it's just what you get closer and closer to. Okay? So all these have a limit of 2 as x approaches 1. Okay. Properties of limits, these are important. Okay. Suppose you find the limit of f of x and you have a limit of g of x. Pause this and write some of the stuff down first, guys. Just trust me. Okay. So your limit of f of x as you approach c is L. Your limit of g of x as you approach n is, or c is m. Okay, your sum rule says you can add them together. If you're adding two functions, you can add their limits. Good. Number 2 says same thing with subtraction, right? Product rule says if you're multiplying two functions, you can multiply their limits. Let's multiply. Okay, so you can add, subtract, and multiply your limits. Okay, if you're multiplying, adding, subtracting your functions. Constant multiple rule. If you have a number times your function, you can just times that number by your limit. Okay? Quotient rule. If you divide two functions, you can divide their limits as long as m does not equal 0. So these are all pretty obvious. You can add, subtract, multiply, divide, and times by any number. Times by 3. Then you times your limit by 3. The last one is the power rule. Okay? Your limit, if you take your function to a power, you can take your limit to a power to get your limit. Okay, so if you know the limit of a function, take that function to like the second power, take the limit to the second power, find the new limit. Okay? Okay. Other properties down here. Your limit of any number is just that number. Like your limit of 3 as x approaches 4 is 3. Okay? Your limit of x as x goes to 3 is 3. That's what those say. I gotta check for time, guys. I gotta rumble. Alright, let's use example of properties of limits. Use any of the properties limits to find limit at 3x cubed plus 2x minus 9 as x approaches c. Okay. So I'm going to split this up. Okay. We can do this due to our no pen. Okay, hopefully it works. Plus your limit as x approaches c of 9, right? So you can break it up. Well, this one is just 9. That was one of our properties. This one is 2c, because you just plug the c in for polynomials. Easy. And this one's 3c cubed. Yes, that is the answer. Sorry. Because with polynomials, you just plug in that number to find your limit. Okay? For example, your limit of x squared plus x as x approaches 2 is 2 squared plus 2. Or 6. You just plug it in, guys. Polynomials, you just plug. Polynomials, plug. Got it? Let's try another one. Polynomials, plug. So your limit is plug in that 5. Okay, you're plugging it into that function to see what you're going to approach, because that's what it's going to be equal to. If it's equal to it, that's what you're going to probably approach. So 4 times 25 is 100. Next 10 plus 6, it's 96. All there is to it, guys. This pen might die again. All this is saying, I'm gonna put this in here. All this is saying is that for many other functions you can do the same thing, but be careful. Sometimes you get funny results. Okay? Be careful. I got an extra 10 seconds of pen charging time. Okay. For example, let's try this one. What's your limit as x approaches 0 of this beast? Well, I'm going to plug it in. What am I going to plug in? Well, my x is approaching 0. Okay. My great pre-calc teacher taught me that sine of 0 is... What's my sine of 0? Anyone? 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 0. Okay. What's my cosine of 0? It's 1. So my limit as x approaches 0 of 1 plus sine of x over cosine of x is the loneliest number. Let's try this one out. Okay, Mr. Wilder, you tell me just plug it in. So I'm going to plug in 0. Can't divide by 0. Okay. If you can't plug it in, graph it. So I graphed it over here, right? And as my x approaches 0, well, I go to negative infinity. That's negative 8. But I also go to positive infinity. So my limit, since I can't plug it in, and I don't approach the same number from both sides, my limit is undefined. Okay? You don't have to always have a limit. Sometimes you don't. Okay? Got it. Beautiful. We're almost done. Guys, remember, some of these videos will be longer in pre-calc just because it's calc. Okay. Now, before I showed you that limit wasn't defined, but it would have been if we made it a two-sided limit. Okay, this is noteworthy. I know it's a lot of writing. Sorry. Okay. What this says is you put, I talked about a little bit, you put a plus or a minus. Can you guys see that? Is there a zoom button in here? Click my face. Yeah, it's a plus and a minus. Come on. This says you're approaching from the right side, the positive, right? This says you're approaching from the negative side, the left side. Left, right, left, right, left, right. Okay? Let's try it out. Okay? So this first one says, what's my limit as x approaches 0 from the right side? So I'm coming from this direction. Okay, as I approach 0, I get closer and closer to 0. Okay. This one says, what's my limit of fx as I approach 2 from the right side? Okay. Well, you can see my function's not defined here, right? There's nothing here. So I'm undefined. Okay. This says, what about when I approach 2 from the negative side? Well, here I'm going up, 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 and I'm getting really close to 4. What about as x approaches 2? Well, it's undefined because it's already undefined as I approach from the positive side. Okay. And what about as I approach 3 from, that's a positive. So I'm going from the right. As I get closer and closer to 3, I get closer and closer to 0. Okay, that's all I got for you guys. Make sure you're bringing questions. Enjoy.